Okay, number 49. I'm going to divide both sides by 3. So I have -2 on the left is equal to cosecant of theta divided by 3. The cosecant trig function is a reciprocal of the sine trig function. So instead of finding the cosecant of theta divided by 3, I could find the sine of theta divided by 3. And I want to know where that's equal to -1/2. Now, the question is from 0 to 2 pi. When I have this theta divided by 3, theta divided by 3 is a horizontal stretch of the graph. That means that instead of going from 0 to 2 pi, instead of doing one complete cycle from 0 to 2 pi, it's doing a third of a complete cycle from 0 to 2 pi. Okay, 1/3 theta. So it's only going to do 1/3 of the entire graph from 0 to 2 pi. You guys are used to that when you're graphing. You do, for the sine curve, period is 2 pi, so you do 2 pi divided by b. If we thought about it that way, you have a sine b theta. Then your period is equal to 2 pi divided by b. So in this case, I'd have 2 pi divided by 1/3, which is equal to 6 pi. So this graph is stretched out from 0 to 6 pi. So we look at that graphically. If I look at it from 0 to 2 pi, then my parent graph goes from 0 to 2 pi, like normal. And so negative sine of -1/2, or sine equals to -1/2, would be at the pi over 6's in both quadrants 3 and 4, so 7 pi over 6 and 11 pi over 6. But this graph's been stretched out to 6 pi, so it completes half of its cycle at 3 pi, or it completes a third of its cycle at 2 pi. So from 0 to 2 pi, if we look at a third of the cycle, a third of this graph, let's see, 2 pi divided by 3. 2 pi divided by 3, it's going to be about right here. Okay, because then 4 pi divided by 3, and then 6 pi divided by 3. So my box is a little bit off. But a third of my graph doesn't even get into the negative values. Okay, from here. If I drew this out from 0 to 6 pi, you could see what I mean. Okay, so I do my 4 dots for my key values. Here's 6 pi, so half of that is 3 pi. Half of that is 3 pi over 2. So 3 pi over 2 is the first tick mark, plus 3 pi over 2 is 6 pi over 2, or 3 pi. 6 pi over 2 plus 3 pi over 2 is 9 pi over 2. 9 pi over 2 plus 3 pi over 2 is 12 pi over 2, or 6 pi. So my new graph that's being stretched out doesn't get into the negative values until 3 pi. So from 0 to 2 pi, okay, which we could estimate is about right here, from 0 to 2 pi, there is no negative values. There are no negative values there for the curve. So the answer to this question then, since there are no negative values there, there's no angle that sine can equal -1/2 from 0 to 2 pi. So this is undefined. Now, if it wasn't from 0 to 2 pi, we could still solve that. So we could solve this for a general solution, but there's no specific answer from 0 to 2 pi. If I did want to solve it for a general solution, solve it in the general solution. I know that, let's see, we would take theta over 3. Okay, I took the inverse sine of theta over 3, gives me theta over 3. Inverse sine of negative 1/2. Sine is equal to negative 1/2 at 7 pi over 6 plus 2 pi n. And 11 pi over 6 plus 2 pi n. So those are the values on the unit circle, where sine is equal to negative 1/2. You have a pi over 6 in quadrant 3 and a pi over 6 in quadrant 4. Whenever we're solving a multiple angle problem, which means that there is a scalar multiple in front of theta, or in this case divided, we're doing 1/3 times theta. Whenever there's that horizontal stretch or shrink, okay, this is a horizontal stretch, we need to set up with the general solution. So to solve that, I multiply everything by 3, and I get theta equals 21 pi over 6 plus 6 pi n. And I get times 3, 33 pi over 6 plus 6 pi n. I can reduce that. 21 over 6, divide the top and bottom by 3. So 7 pi over 2. And 11 pi over 2. If I look at my graph that I drew in pink and black, the 7 pi over 2 corresponds to that first purple arrow, and the 11 pi over 2, which is close to 12 pi over 2, corresponds to a value close to 6 pi at the second purple arrow. So that's where those values would be. So from 0 to 2 pi, it's undefined because the answers lie outside that range.